Hey, we're back. So I'm going to talk about a problem with texture mapping called aliasing. Now, aliasing is a common aliasing is a common problem anytime where we have sampling. So it's in audio, it's in video, it's in images. And it's basically aliasing are artifacts or errors. And what they're caused when we have a mismatch between sampling rates, caused by a mismatch. And in our case, the sampling rate is the sample of the texture, the resolution of the texture, and the resolution of the actual image. So mismatch between the texture, resolution, and its associated raster resolution. Now when this happens, we have some necessary problems, and it's that we either have to shrink the texture to make it fit or stretch it out to make it fit. So let me draw out what this looks like. Let's say we have a texture patch about this size here. That's our texture. Okay, and I'm going to draw our scene. Okay, now in this scene, I'm going to draw a little box. Now, a rectangle, I should say, and it's going to be the floor, except it's going to be going into 3D, okay? Imagine this as the floor. So here's the front, okay? And here's the back, because it's far away. And so we get this perspective projected floor. Cool. So this helps us illustrate two different problems with texture mapping. When I'm drawing this region of the floor up here, this goes to a tiny little patch, okay? So this is a problem called minification, where the texture patch has to get smaller. And when I'm drawing down here, because it's so close to the camera, it gets stretched out. Okay, this is a problem called magnification. And in both cases, we have this aliasing problem where this mismatch in resolution causes artifacts. So let's learn a little bit more about that. First, I'll talk about minification, where we're making it smaller. So I'm going to draw out 1, 2, 3, 4, 5, 6. I'm going to draw out a little patch. 2, 3, 4, 5, 6. So a nice little 5 by 5 texture. And now imagine our texture looks like this. Okay, so nice little black lines. Just like that. Something like this. Perfect. And then now I'm going to draw this into a 4 by 4 area. That's a 3 by 3. Okay. So I'm drawing this into a 4 by 4 area. So this on the left here is my texture. On the right here, this is my raster area. This is where I'm squishing it into. Now in this case, it's only 1 pixel smaller. But we can see as we start rendering it in that we're going to have some funny things happen already. Okay. So when I'm shading this one, it comes from this region here. Now the next pixel that I shade, it's actually going to map nicely to the next pixel. Okay, but this one here is going to map, it's going to skip over there. So far the rounding error works out just fine. Okay, but this last pixel is going to map over to the last one. So we're going to have this kind of, there's going to have no space in the middle between those last two lines. So as we scan across, it scans the texture unevenly. Because of rounding. Okay? So the problem is that we have more than one pixel per pixel. Okay, so if we have more than 1 pixel per pixel, we find the closest match, and we have this uneven result because of rounding. Now this approach of finding the closest match, this is called the nearest. I should write that out. So using the closest match you'll often see this called the nearest neighbor approach. And all you do to get the nearest neighbor is you calculate the ratio, right? On the right, it's pixel 1. You translate that with a ratio to that texture, and it's your nearest neighbor. You just find the best fit, the best match, okay? So you can see that we get this problem. Now, if I rotate or slightly change or slightly move the object, you might get a slightly different pattern, okay? And I'm going to come back to that. But little differences in how it's calculated, how it's rotated, or how it's moved or scaled will result in different rounding outcomes. Okay, so this is all dependent on rotation and scale, and little changes have big impact. All right. So one problem that we'll see from this is what's called a Moore pattern, and we've all seen them, and you'll recognize them immediately once I start showing you them. This is when this resolution mismatch causes a regular pattern of interference. When the resolution mismatch causes a regular pattern of interference. Okay? And so this regular pattern sticks out to us because we see regular patterns even though it's not supposed to be there. Okay? And this creates very salient artifacts. And salient means it sticks out. Okay? So that's a Moore patterns, this regular interference. We also have this problem of shimmer. And shimmer is an animation effect where the aliasing changes as we animate. So you can imagine, as I mentioned before, this difference here. It'll as it gets slowly rotates or shifts size slowly, you'll get it shifting between those two, and you get what's called a shimmer because the lineups keep changing. So let's look at some of this in slides. And I'll also show a sketch. So here's slide 27. Doesn't look like it's the right size on the screen, does it? So here's slide 27, okay? And you can see here, this is what we mean by aliasing. So here's the texture I'm using, okay? And then down here we textured it across the surface. So in some spots, like where it matches nicely, it looks great. But then as we get further away, we get really strange artifacts, like lines that don't exist, these big white spaces and big solid lines that don't really exist. That's an aliasing artifact. Then we have this region here where you have big long sections that look like, wait a second, it's white, then look like they're lined up differently. This is just a result of the aliasing artifact, the way the math lines up. And this is a Moore pattern here. You can see the circle. There's circles coming out of this. But there's no circles in our pattern. This is just a Moore pattern. The interference lines up in a way that makes it look like it's a circle for you, okay? And here's a demo I wanted to show. All we're going to do is show some textures here with that'll show the shimmer and aliasing that I talked about. So I'm going to actually, first of all, just show you what it looks like if I run it. And it probably won't come through in the video, but you can start to see some shimmer here. So what I'll do is I'm going to zoom all the way in, like all the way. Now as it gets close, now you should be able to see that shimmer. Look on both of the Comp 3490 and on the bricks you get the shimmer. As it gets closer, you don't really notice that so much. You go back out again, look at that. It should be jittering and shimmering, and you get that funny movement happening. That's a shimmer. If you don't see it, download the demo and run it, and you should get it, but your graphic card might have settings that turn that off, that fix that, but hopefully you can see that. Okay. So the next problem I want to talk about is, this was minification, so the next problem I want to talk about is magnification. Now you might be thinking, magnification, geez, that sounds easier, Jim. We're just making things bigger, we can stretch it, no big deal. But it's not quite that simple. But this happens when we have more than one pixel per texel. So I'm going to draw out a similar but a little different. 1, 2, 3, 4, 5. So 4 by 4. Okay, I'm going to draw out a 4 by 4 texture. And this time I'm going to draw a 5 by 5. 1, 2, 3, 4, 5, 6. Okay, 5 by 5 raster. Now, as I'm shading this in, I'm going to have similar problems as before, except now it's going to be a little different. Here's my texture. Okay, cool. As I'm scanning in across the top here, the first one maps to the first one as expected. Good. The second one is going to map also to the first one, which should use the same color. It's also going to map to the first one, so it goes black as well. The next one maps to the second one, the next one maps to the third one, and the last one maps to the last one. So we actually get this kind of pattern. And so it's not so bad. We have black, white, but what you'll notice is it's disproportionate because of the rounding effects. So you get this weird mismatch balancing going on, okay? So you often get them uneven. You get chunky rather. They look chunky, okay? This leads to jagged edges, as I'm going to show you in a moment on the slide. Jagged edges and things whenever anything moves. And just like with the minification, any animation makes this move around, and you get shimmer with this as well. So let's look at a slide. Here's an example of aliasing. Here's magnification at the bottom here. You can see, look at the jaggy lines. There's no reason why it shouldn't be smooth. Look at how nice and smooth it is down here where it's supposed to be. Right? Looks great. But here we get these really jaggy lines because of the sampling mismatch. And then we have a very terrible Moir pattern here, and the aliasing really breaks down until we get basically noise at the back end. And you get this circular Moir patterns. You know, it basically, you can't recognize over here that it's supposed to be a tile floor. It just looks like a mess, okay? So this is texture aliasing with texture mapping, and we need to learn how to fix it. And when we come back, we'll learn how to work on it.